Can you guys still hear me or see me on Twitch? Can somebody confirm, please, that you're seeing me on Twitch or hearing me on Twitch?
Yep, you're good on Twitch.
Okay. I try to keep the Twitch chat open, but honestly, it's a lot easier for you just to say something and interrupt me because it's just much easier. If I try to keep a Twitch tab open, it actually slows down everything. Slows down my computer, and I have to stop what I'm doing and look at the Twitch chat. So it's just all around better to interrupt me. I mean, I guess I can check the Discord chat as well, but it's harder to pop around with multiple windows all the time. Okay, guys, so let's talk about some surfaces, surface development, materials, and so on. So what you want to do, and what you want to do for homework, is begin to add some kind of material to every object in your scene. And specifically, what you want to use here is going to be under Window, Rendering Editor, Hypershade. Go to your Hypershade. Once you're in your Hypershade, you want to start adding materials specifically of one type. Concentrate on the top of your Hypershade for right now. Concentrate on this. This is what's really important. We have this, which is our node-based editor, and we'll get more into this later on. But this is how we can see our material as a node. This is how we sort of see the material as a thumbnail, and so on. So let's start, I guess, by actually... I can go to Edit, Delete Unused Nodes. What this does is it deletes any materials that are not currently attached to objects. So if I do that, then that kind of cleans up my Hypershade a little bit. You can see a few were deleted. You can also see that my Paint Effects all generate materials. Sadly, these Paint Effects materials are terrible. So we basically have to replace our Paint Effects materials with physically accurate materials. That's going to be here under Shader. Arnold, Shader, and we want to use the AI standard surface. And actually, this AI standard surface is everything. It's what you're going to be using for the remainder of the term. So whatever it is you're trying to add a material to, like say candlestick, then rename your material candlestick. And I mean, if you want to, you can even rename it candlestick gold or brass or whatever the material happens to be. Then the secret to the sauce, the really important part, is to now start with a preset that is close to what you are trying to create. So if I'm trying to create a brass candlestick, I can go up here and look, do I have brass? No, I have copper. That's pretty close. So I go to copper, replace, and you should see this immediately updates this shader ball preview. And what's pretty cool here actually is we can blend these presets together. So I could say, for example, if I start with copper, then I could like blend it to like 50 or 25% chrome. If we say 25% chrome, we could blend 25% chrome into our copper, so we get a more reflective thing. Or I could even do that again. I could say blend 10% gold into it also. So you can definitely blend these materials as much as you want. You can even blend stuff that doesn't even make sense. I could say 50% jade, and now it's 50% jade. That really doesn't make sense, but you can do that. So it makes more sense to blend brushed metal, perhaps, or whatever. To blend metallic presets makes a lot more sense. A car paint metallic. Yeah. Next, let's talk about the physical attributes of the material. So we have base color first. This is base color weight. This is going to be the intensity of the color. If you have 0 intensity, that's like 0 color, black. Go figure. If we're at 100%, then that's going to be 100% of this color. Next, we have diffuse roughness. This is almost like how sandpaper it is. It's like kind of microscopic roughness. We have metalness, which is, well, what it sounds like. how metal is the object. And these typically are set in 1 for 100 or 0.5 for 50%. And I think at the moment we had 0.75 for like 75%. I can't do it right now. Specularity is really important too. Specularity here is shininess. So this is going to be, if you have a glass object or a metal object, this is basically how shiny the object is. And again, weight or intensity is what you want to adjust. So if I pull the weight down, that's going to make the object a lot. Let's just pull it down to 0. We should see the shininess go away, but it's also tied to roughness. So let's pull the roughness down too. Oh, wow. It's a little strange that I see something so reflective. Definitely specularity, when we're down here at 0, we should have less of this reflective nature, but it's probably tied into, it's tied into how metal the object is. So note again, if I take the metal to 0, I take the roughness maybe to 1 and in diffuse color, and then take the specularity again back down to 0 and roughness to 1. Now I'm getting something that no longer looks glass, metal, plastic, or anything close to what I started with. So I guess what I'm saying is we know it's a metal object, so keep the metalness up. I think 0.75 is where we were. Then on to specularity. This is again how shiny. You can almost even replace the word specular with shininess. It's the same thing. So
Sorry. I'm in a Mexican restaurant. What would you like me to bring you back for?
I'm good.
Okay.
Yeah, thank you though.
Call me when you get time if you want.
Sure, sorry. I
Sorry
had
about you.
Mexican last night. In the middle of a demo, like quite literally. Anyway, specularity, right? This is the amount of shininess. So again, if you turn up the specularity, you should see this become shinier. The reason it's not is because of how rough it is. So if we take the roughness all the way down, now we're getting the shininess back. And note that as I turn the roughness up, look what it's doing to the specularity. Think of this in terms of if we want something really, really metallic or really, really shiny, then probably our roughness should be pretty low. If we want something that looks more like, I don't know, velvet, I guess, you could turn up the roughness like on a velvet surface, and you can see the rougher I get it, the more that specularity gets diffused or gets blurred. It doesn't quite look like glass or chrome anymore. So I'll leave this up to you as to how rough you want the specularity to be, or even how much you want the specularity to be. That's something you get to decide. And again, I always recommend starting with presets and then working with the preset first. Transmission, by the way, in case you're wondering, transmission is going to be kind of the fancy new way of saying translucency. I don't know why they changed this. In the old renderer, we actually had translucency as an attribute. We don't have that anymore. We have transmission. It's kind of weird to me, but the way that you can think of it is if the weight is 0, then it's opaque. And if I move the weight up to 1 for 100%, now I basically have something like glass that's completely transparent. And something in between, like 0.5, would give you half and half. It would give you translucency, so then the light would go through half of it. The light would pass through half of it at 0.5 for 50. So anyway, that's a lot for a candlestick, but select the candlesticks, which look like they have gold on them currently. Right click here, and if you have a middle click, hopefully you do, then you can just use middle click to drag onto the object. So middle click drag. I'm on a trackpad, so I'm going to right click, assign material to selection. And now I have my nice brass. It's more like bronze. I don't know. It's some kind of weird chrome bronze thing, but there it is. We can go back to making glass, right? So if we were to go to, I've already got one in here, but let's just go over it again very quickly. Arnold, shader, AI standard surface. Preset, glass, replace. And whenever you make glass in Maya, always make sure, well, name all your materials, but always make sure to add thickness to whatever the glass object is. So in the case of this wine glass, it has to have thickness for the glass to look good. Assign the material. In the case of this crystal ball, again, select the crystal ball, right click, add material, and you can see in this case I put a skull in here because I was like, crystal ball's cool, but a crystal skull is cooler. So then I took my skull and I made that glass as well. And again, select the object, right click, assign material. And now the skull is glass and the glass is glass. And these guys are gold, or bronze, I guess. So let's do something easy. Let's go with this plate. So if we want something like relatively easy, let's go, whoops, a little sneak preview there. Let's add a new material for the plates. I want to go to, again, Arnold shader, AI standard surface. Hopefully you see a trend here. Name the material. Let's call these plates so you know what they are. And I mean, if you know that you want them to be plastic, you could say plates plastic. Typically, I always start the name with the object and then finish the name with the material, because if you just put plastic, that would be pretty confusing to find later on. But how do we make plastic? Well, is there a preset? Yeah. Well, that's an easy place to start. So, plastic, no problem. Now we can change the color of the plastic. What color should these plates be? Somebody tell me, so I know you're there and listening. Plate color, guys. What? Say something. Plate color? Anyone? Sigh? What did you say? Somebody give me a color, any color. I don't care.
I said orange.
Orange. Thank you. Perfect. So we'll make the plate color orange.
Brown.
Brown. I think I like orange better. I mean, we could start with red and then just pick a nice orange color. There we go. So now we have orange plastic. Maybe not very exciting, but with the specular roughness, we could either make the plastic more or less shiny. So if we wanted something really closer to glass, we could pull the roughness way down. And you can see I get reflections closer to glass or metal. If we pull the roughness up, then it's going to be maybe closer to what you might expect from a plastic plate. We also have index of refraction. That's something I will address a little bit more later, but the idea is it's how light bends through a surface. So refraction means how light bends through a surface. Index of refraction means what's the angle, literally the angle that it bends through the surface. And everything will have a different angle. Skin, by the way, has an angle of 1.33. Diamond, I think, has an IOR of like 1.45 or something. But there's a giant list, by the way, so you can actually just simply Google IOR list, and it will tell you the number for almost anything. Let's try thin plastic. Ooh, that's got a lot of transparency. So what do? We pull back on the transmission because we don't want it to be quite that. And remember, 0.5 is like 50%, 0.3 is 30%, and so on. So you can think of 1, in this case, as perfectly transparent like glass, and 0 to be perfectly opaque. So what do we want for this plastic? Maybe we'll do something that's like 0.2 or 0.3 or 0.32. So we have a little bit of transparency. And then I'm really curious about, well, where's the color coming from? Because it still appears to be white. We can turn up base color. So if we want that orange back, we could say 50% base color and then pick that orange again. And now we have kind of an orange semi-transparent plate, which is kind of shiny. And again, we could change the roughness, turn up the roughness so it's not quite so shiny. And let's see what it looks like. I'm pretty curious. Let's find out. So there's a plate. Remember, to add this, what do we want to do? We want to right-click Assign Material. Let's take a look at how this renders. I'm going to hide the crystal ball because it takes forever to render. So I'll hit H for hide. And then I will re-render. Okay, right off the bat, I'm not sure. Nope, it's definitely not rendering the right camera. So really, really important, guys. Go to your render dropdown, your render menu, and make sure that you're actually rendering from render camera. That's why it's there. That's why we have it. Don't render from the perspective, obviously. So this is taking a while. The next thing I want to talk about is how do we speed up the render process? Because, wow, this is painfully slow. So how do we speed this up? Does anyone have any ideas?
You could change the resolution size. You could reduce the sampling.
Yes.
You could change the resolution, like of the DPI as well.
Yes. I mean, I'm all the way down here at 640 by 480. So you're correct, but at 640 by 480, I really don't want to go any lower. You know, that's as low as I want to go for resolution. So I don't think it's possible to really go too much lower for resolution. I mean, you can go to 320 by 240, but that's not going to be good to see any detail. And even here at 640 by 480, it's still pretty hard to make out detail. You're absolutely right about the sampling, though. The default sampling in the render settings is going to be 2 and 2 and 2 and 2. You could lower that to 1 and 1 and 1 for your diffuse sampling, for your anti-aliasing, and for your specular sampling. And that would definitely make your render time much shorter, but at the cost of a lot more noise. You would actually have to, like realize that a sampling of 1, 1, 1, you know, across the board, your render time is much faster, but you end up getting a lot more noise because of obviously the higher your sampling, the less noise. So all of those are good ideas. I'll hit the escape button. Come on, Maya, don't crash. Just quit the render is all I want. Just stop the render. Oh, good. Okay, it actually stopped. So I want to talk about some other ways to fix your rendering time. By the way, this is, hopefully you can see this, but this is what my plate looks like now. It's pretty cool. My glass looks pretty cool. I'm not sure I'm happy with my candlesticks, though. These look kind of bad. But plates are kind of okay. Glass seems fine. So here's what we can do. We can use render region. That's one way to fix the problem. So if I wanted to tweak my plate, for example, go to my plastic plates, and I'm going to go to the plastic plates, and I'm going to just change a few things around. Come on, plastic plates. Where are you? Why won't you? Oh, God, Maya. Well, it's here anyway. So then change the color to my plastic plates. I think I'm going to go with blue, for example. And let's maybe under transmission make it a little bit more transparent by increasing this. Remember, transmission of 1 is basically completely transparent. So if we have something like 0.6 or 0.75, then it'll be semi-transparent. Yeah. And now, how do we test this? Like, how can we see what this looks like? Well, obviously, I can save this image, draw a little box around what I want to render, and then use render region. So render region is your friend. Use render region all the time. Please, please, please don't render the whole image every time. That's crazy. That's just way too much. You don't need to wait that long. So render region is one way. The other two methods mentioned absolutely lower your resolution to 640 by 480. Probably not less than that. Also, change your sampling to either 1 or 2 in the render settings. And then, maybe most importantly, use render region always, because that'll save a lot of time. And you should notice in your task manager that your CPUs should be working pretty hard. This is telling me I'm using about 60% of my CPU. I'm a little surprised it's not using 100%, but it's working slowly. Yep. Okay. Yeah, so render region finally finished. It's got this interesting purple blue kind of thing going on. I'm pretty happy with it. So what's yet another thing we can do to save on rendering time? By the way, don't forget, if you've saved the image up here, hopefully you have, then you can always use your slider to pop back and forth so you can maybe see the differences between before and after. So I want to do that again, where like just use your slider. So this would be before, after, before, after, right? So as long as you remember to keep this image, this little icon up here, keep image, then you can always compare your previous renders. Again, like this, just slide back and forth. Before, after. And we can see that the before one has less transparency and is orange, and then this has more transparency, and the blue interacts with the candlelight. Looks pretty good. So how can we make the render time even faster than what we currently have? Because this is still slow. So what can we do? Well, another thing we can do, let's say I want to change this candlestick and I'm like, no, I just want gold. Screw this weird bronze strange thing that I came up with. I'm going to go back to gold and I'm going to say replace. And this will replace 100% with gold. So now the candles are gold. Check this out. Instead of using render region, I can go up here to my render dropdown and check render only, and this is important, render only the objects I have selected. This is a gotcha, because this is really great for speeding up your render time, because again, it's only going to render what you have selected, so I can render just the candlestick. So I'll show you what I mean. Select just the candlestick here and here. I still like to use render region out of force of habit, But now we should see only the candlesticks update, hopefully, and nothing else. Yep, there we go. And now you can see how fast that rendered. How fast did that render? Well, I'm glad you asked. I think the render time is 12 seconds. See it down there? Render time, 12 seconds. So this is really, really useful to make things render faster because you just select what you want rendered. And if you combine that with render region, you shouldn't be waiting around forever. And then you can compare, this is before, this is after. I think I like gold better, personally. Just remember you have it on. So anything you want rendered, you need to shift select that object. Because the problem with the setting is that you might forget that you have that on. It's definitely something that's happened to me many times. I totally forgot that I had the checkbox on for render only selected objects, and then I'm wondering, why is everything black? Why is the render black? It's because nothing's selected. So I repeat, it's a good way to speed up your render time. Only render the objects that you're working on, only worry about those materials, and only have them selected when you render. So that should really, really save a lot on your render time. So what was taking like several minutes to render is now hopefully taking like under a minute to render. Still doesn't like this plate very much, apparently. But it's working. Cool. We have a lot of noise here, but other than the noise, I mean, everything else seems to be okay. Who's got questions for me? Anyone at all? Questions about saving on rendering time? Questions on the AI standard surface? AI standard surface. Preset. Wax. Replace. What color do I want my candle to be? I hear a beep, so that indicates a question.
Oh, I had a question about the AI standard surface.
Yes.
So are these presets just like, could you make, I don't know how to ask this. I guess like, are the presets all using the same system, or are there like things specific to the glass preset or specific to like the gold preset? I guess, if that makes sense, I don't know.
No, they're all the attributes are the same in the AI standard surface. It's just a question of how the attributes are being used. So this is where I hate to say, look up the documentation, but literally just say Arnold document. Here it is. Arnold document AI standard surface. So here it is. In fact, I'll put it in your, here it is. I'll put it in your general chat, or how about this? I'll put it in the announcements, because this is like practically a book. I mean, we're talking 10, 15, 20 pages, right? So I don't have time to go over every single attribute. I want to go over the important ones, like obviously how metal an object is. So that's sort of obvious, but it will actually tell you the difference or show you the difference. So this is with no metal, and then this is like 100% metal, right? So it does a pretty good job of showing you what the range is between these different attributes. So for example, specular is one that I've talked a lot about. And if we go to specular, here, this again will show you, okay, zero specular means, or zero weight in specular means no shininess at all. This is 50% shiny. This is 100% shiny, 1 being 100% specularity, and weight being how much shininess we have. Specular color is a little bit hard to understand, but imagine if the reflection had some color. That's what this is here. So the reflected color, or or reflected specularity, or what color is the shininess? That's here. Roughness we just kept talking about, but I want to really drive this point home because specular roughness does make a big difference between something that looks very much like glass and chrome versus this, which looks more like brushed metal, I guess you could say, or rough metal. So this is, again, the roughness of the specularity. And what's the difference? Well, the rougher the surface, the more light scatters upon hitting that surface. So that roughness is called like microsurface detail, almost like how sandpaper the object is. So all this stuff you can find in your AI standard surface documentation, which I'm going to say used to be included in Maya years ago and is not anymore. So sadly, you have to, Google it. I'm sorry. Arnold documentation, or Arnold standard surface documentation. I'll pin this as well. It's super important. Again, I can't go over every single attribute, but I want to go over the ones that really, really, really are incredibly important. Transmission being translucency, for example, or semi-transparency. Specular being shininess. Base color being exactly that. But then we have things like sheen, and emission. And emission is basically your glow. So for those people that want to make glow, there it is. There's your glow. I know you want to make glowing stuff. There it is. It's right there. Emission. Geometry is how we can make cutout objects or make masking. And it's also where our bump mapping is, by the way. So anyway, we have a lot of these to play with. I'm making a blue candle. So I want the blue wax to be blue. And I want the transmission, which again is how much the wax is actually translucent. If it's too low, then you have no translucency in your wax. If it's too high, then it's just completely see-through. So your wax preset tells you exactly that you want 0.8 or 80% translucency. And then you can go and change the colors. Like I was like, no, I want a blue candle. And the transmission color is a little bit weird, but just try to imagine as light passes into the blue candle, it would probably be a little bit lighter blue. Scatter is how the light scatters through. Again, maybe light blue. Okay, so let's now apply this new wax. We should always name our material. So we'll apply this new wax material to our candles. And yes, this is what you have to do for homework, is basically make an AI standard surface for every object in your scene. Now, there's a couple of exceptions. Like here's one exception right here. Both of these candles are the same wax, so I want to right-click, assign one wax material to both candles. And maybe here, like this candlestick is going to be the same gold material. Typically, you really want the same, Typically, for realism, you really want a different material on each object. Obviously, the banana should have a different material than the apple, and so on and so forth. So typically, again, you really, really want a separate material per object. But if you know it's exactly the same candlestick, then you can use the same gold. If you know it's exactly the same wax candle, then obviously you can use the same wax material. So that's the exception to the rule. Now, as I keep saying, we can select the objects we want to render by shift selecting them. And if you have that checkbox on, and it's really important, again, I repeat, to check it. Like, is the checkbox on? Yes, it is. Okay, we'll render that. I think that, I hit escape. You can click escape to get out of your render, but it can be dangerous at times. And I say dangerous because if you've waited too long and you try to escape out of your render when it's like 95% done, you might crash Arnold. You might crash Maya. You might even crash your computer. So if you're going to escape out of your render, you should probably try to escape out in the early part of the render and not wait till it's 95% done. If you escape out in the first 10 to 25%, then usually you can escape out of the render. It won't crash. It'll be fine. But if you are really going to push that issue, you might crash Maya or Arnold, depending on when you hit the escape button. Ooh, pretty. Look at that. I like the wax. See how the point light goes into the wax material? Looks pretty nice. Are you guys following me? Because I don't trust a class this quiet. It's like maybe you're not paying attention. I don't know. Who's got questions? Questions, comments, concerns? Anyone?
I'm watching.
Okay. All right. Let's talk about something that's a little more difficult, and we'll also have a little preview of next class, right? So preview for next class. Once we get past developing the surface, so what's due for homework is everything needs to have an AI standard surface on it. Everything. Every freaking object in the scene needs an AI standard surface. And I don't even care what it is. All of it. Every single thing. So get rid of all of your Lambert materials. Window rendering editor Hypershade. Start creating your AI standard surfaces for everything in the scene. Right? AI standard surface. Boom. Name it. What are we going to do? Wall? Let's do a wall. These are going to be our walls. Our walls are typically white, but not always. And then if you middle click and drag, you can middle click and drag onto the walls, or if you don't have a middle click, you can select the wall, right click, assign material. And now begin to tweak your wall material. Oops, that's not right. One more time. Right click, assign material. There we go. Now we can tweak our wall material. Do we want our wall to be shiny? No. Turn the specularity down to 0. So we just immediately have a flat white wall. And that's fine. Is the wall metal? No. Well then keep this at 0. Is the wall rough? Yes. So we could turn up our diffuse roughness. That's fine. Is the wall transparent? No. Then don't mess with the transmission, because we know that causes translucency. All right, so then what? Can we start with a preset? Well, there's no preset for whatever the wall is made out of. Wallboard or paint. There's nothing here for that. There's plastic, there's rubber, there's skin. So there's not really a preset that we can be starting with. Maybe clay might work if we click clay. But look, see how shiny it is? We don't want this to be shiny. So again, kill the specularity. We don't want the wall to be orange or whatever that is. So then we can put the base color back at white. We can again turn up the roughness. Turn down the specularity. Probably the rest of this stuff we could leave alone. And then we kind of have our wall material done. It's a little boring, but we haven't really added any textures yet. So we can talk about bump mapping at this point, because I think one of the things that we can add that will make this wall look possibly a little better, and of course I can select it and render just the wall just to see how it looks. Bump mapping is something I did not go over with the other class, so I guess I'll give you like a little sneak preview really quick. And I maybe kill the render because I don't want to wait a long time. So bump mapping, again, is something that I guess I'm giving you a sneak preview of this as well. If we go into our wall material and we scroll down to geometry, this is where we can feed in our bump mapping. And we could feed this in as an image, or we could use something called a procedural texture. So let me give you an example. If I were to use cloth, for example, just bear with me. You can actually see immediately what the cloth will look like as bump mapping. You can totally see that right off the bat. And you could even change, for example, procedurally, how the cloth is made by adjusting all these sliders. Now let's see what this looks like when I render it. Don't forget, you can use both the render selected object and you can also use render region. Just make sure the object's selected and draw like a little box and then render it. Render region. So what I'm testing now is bump mapping. And I'm going to tell you straight up with Maya, your bump values typically should be very, very low. So in Maya, if you have a bump value of 1, that usually means like 100% bump. And so that's a lot. So typically when you make bump mapping in Maya, you typically want to turn it down to something really low, like 0.1 or 0.2 or something. Wow, this is taking much longer to render than I expected. Hope I didn't break it. Incidentally, if you're just testing materials, you can hide maybe all but the main source of light or the key light, because the more lights you have in your scene, the longer your render time. So if you're rendering with all your lights on all the time, that again is increasing your render time significantly. So we really want to make sure that we're not like going nuts with our rendering times. So use our render region, use the render selected object, maybe turn off some of the lights. Okay, I got it. I'm not really seeing that bump very much though. In fact, I'm not seeing it at all. Oh Maya, stop crashing. Just escape out of the render, please. Once Maya starts rendering, it has sometimes a hard time stopping, even after I tap the escape button a bunch of times. It doesn't really want to stop. So, like I said earlier, try to hit the escape button at the beginning of the render, not at the end, because your odds of crashing Maya or crashing Arnold or even crashing your computer are a bit higher. Actually, I'll show you guys a pro tip. Hopefully, if you can identify in your processes here where the batch render is, you used to be able to just kill the batch render and not crash Maya, but rather just find Maya's batch render process and kill that. I don't know if that's even something you can still do, but it used to be something you could do fairly easily. I'm not even seeing Maya's batch render even listed anymore. Okay, well, I've escaped out of the render, I guess. Yeah. Oh, okay, good. Let's go back to that bump mapping. I'm running out of time. So I didn't really want to use this bump anyway. If you right click on the word bump mapping, click break connection, then we can kind of start over from scratch. For a wall, I kind of wanted to just use some noise. See how now we have this noise? This is the noise that should appear on the wall. I can play with the amplitude or play with these sliders to basically get the amount of noise I want for my bump mapping. Don't worry, we will review this again. This is just kind of a preview. If you hit the 7 button, by the way, well, sorry, the 6 button, actually, in this case. So the 6 button is actually showing in my viewport what my bump mapping is doing. And actually, I can see that it's way too big. So that's the nice thing about the 6 button. I repeat, the 6 button will show the texture in your window, or in this case, show the bump mapping in your window. So what I'm doing here is I'm cranking up the amplitude, but playing with my ratio and frequency ratio. And you're probably thinking, this is crazy complicated. Why are you doing this right now? And the answer is, it's really just playing with sliders. So anytime you have something that's procedural, it's easy enough to play with sliders until you see something you begin to like here in the shader ball. And then, oh look, now I can see it in my preview, and I can clearly see that this is going to give me, hopefully, this kind of interesting noise on the wall. Then just draw a box and render just that corner. So for homework, guys, again, put an AI standard surface on every object in the scene. Very important. That's your homework. Next class, we're going to pick up with adding textures, which will be due for Tuesday. So basically, you got a week to wrap this up. Hey, cool. My bump mapping looks pretty good now. By the way, your bump is not required. You can play with it if you want, but hopefully you can see by adding some bump to my wall, I get something that's a lot more interesting. And a bump map is typically just a black and white image, although these days we have normal maps, which are kind of advanced bump maps. We'll talk about that soon. But for right now, I want you to see that this wall is a lot more interesting with a little bit of bump on it. See, by adding this noise, I've made the wall have a nice sort of bumpiness or nice texture to it. I guess I'll try to render the whole thing, but we're about out of time. So I'm going to stop the stream and then... crap. I'm going to stop the stream and then I ask people what they need for help. But we've covered a lot. So I'll switch to Discord and see what the questions are.